What if Earth suddenly stopped? Imagine the Earth's rotation grinding to a halt. In reality, this can't happen without an unimaginable force, but as a thought experiment, it reveals spectacular consequences. Currently, our planet spins once every 24 hours. At the equator, that's about 1,040 miles per hour, 1,674 kilometers/hour, because everything land, ocean, air, even you is moving with it. We don't feel this steady spin. But if the ground underfoot abruptly stopped, inertia would fling everything eastward at those tremendous speeds. As Smithsonian Magazine explains, the existing momentum would send things flying eastward, so that moving rocks and water would trigger violent earthquakes and tsunamis, and the now furious atmosphere would scour landscapes. In short, it wouldn't be good. The initial halt would be instantly catastrophic. Earth's current motion. To set the stage, Earth's rotation today is remarkably stable. A person at the equator moves eastward, approximately 1,040 mph, 1,674 kilometers/h due to the spin. This is why the sun appears to rise in the east and set in the west each day. Higher latitudes closer to the poles move slower. At the poles, the rotation speed is essentially zero. The same physics that keeps satellites in orbit also keeps everyone and everything on the surface. As a result, we never feel the steady rotation at all. In fact, astronauts in orbit see the Earth rotating beneath them continuously. The Earth also orbits the Sun at about 67,000 miles per hour, 107,000 kilometers/h. But we don't feel that either, thanks to smooth motion and gravity's pull. In this discussion, we focus on the Earth's spin stopping, but we will also address what happens if Earth's orbit suddenly stops. All these scenarios are theoretical catastrophes. As notes, no natural mechanism could instantaneously stop Earth's rotation. It simply requires far more energy than exists on our planet. The instant catastrophe. If Earth's rotation were suddenly arrested, the consequences would be like a global-scale car crash. By Newton's first law of motion, everything not solidly anchored would keep moving at the original speed. In practical terms, everyone and everything on the equator would be hurled eastward at approximately 1,040 mph. Geoscientist Joseph Levy, Colgate University, explains that you would be launched eastward, probably at hundreds of miles per hour depending on where you lived. In fact, everyone at non-polar latitudes would be thrown along the surface at hundreds or over 1,000 miles per hour. You might imagine just casually walking on a beach. But if the ground suddenly stops, you don't walk, you fly. You would slam into whatever lies ahead: ocean, mountains, city at lethal speeds. The entire atmosphere would also keep spinning. In practice, this means a supersonic windstorm sweeping across the globe. Emphasizes, since Earth's rotational motion is about 1,000 miles an hour at the equator, if rotation stops the air, and everything in it would literally keep going, generating winds that would shred the surface. The Smithsonian expert notes, the atmosphere would scour everything in its path. These winds alone, moving at near 1,000 miles per hour, would rip roofs off buildings, uproot forests, and fling debris worldwide. At the same time, the oceans, which had been circling with the spin, would surge across continents. The inertia of the ocean's mass would slam water as huge tsunamis. Business Insider quotes Levy, "Water would go flying eastward like everything else, causing chaos." Science Focus adds that even a slower stop over a minute still subjects everything to a 0.75 g sideways force, more than enough to topple buildings. The result? Mega tsunamis thousands of feet high, smashing inland globally, combined with hyper-strong winds and relentless seismic shaking. In summary, the very instant rotation stops, massive earthquakes and tsunamis would erupt worldwide. Moving land masses would grind and shift, while ocean surges wash across continents. Buildings not bolted to bedrock would be torn apart by sheer inertia. The destruction would be nearly total, except at very high latitudes see below. In such chaos, hardly any human infrastructure or natural landscape could survive intact. Oceans, atmosphere, and geology. With rotation gone, the dynamics of water and air change dramatically. First, without the sideways push centrifugal force that normally crowds water at the equator, oceans would migrate toward the poles. BBC Science Focus explains, without centrifugal force, the oceans would move towards the poles, dropping ocean depth by 8 kilometers around the equator. In effect, equatorial regions would dry out and end up as new dry land, while polar regions flood. One estimate says north of Spain and all of Antarctica become a giant ocean, leaving a wide central belt of land. This is because the equatorial bulge, due to rotation, collapses into a more spherical Earth, sending water to higher latitudes. Meanwhile, the atmosphere's rotation-driven circulation would collapse. On a normal Earth, warm air rises at the equator and flows poleward, driving trade winds and weather patterns. With half the planet in permanent day or night, Sci-Focus and Business Insider explain, weather would be extreme and chaotic. The day side would form a hot desert under months of uninterrupted sun, boiling seas and roasting everything. The night side would plunge into freezing darkness. The usual east-west zonal winds vanish. Instead, Business Insider notes, fierce cross-terminator winds would whip across the terminator, driving frigid air from night side to day side and scorching air back across the world. In very short order, the dayside sky temperature would climb well above 100 degrees Celsius. All open water and moisture would evaporate. In fact, Science Focus points out that lakes and rivers would boil away. The planet's surface on the sunny half would become an uninhabitable furnace. On the flip side, the dark half would freeze, killing most remaining life and locking water into polar ice. Only a narrow twilight band near the day/night border might remain somewhat hospitable. Overall, climate would be utterly transformed, one hemisphere an oven, the other an icebox. Impact on life and infrastructure. Human constructions and life forms wouldn't fare well. As noted, the inertia of a stopped Earth would exceed the strength of buildings. Levy explains that even sturdy structures can hold hundreds of people because they resist compression but would fail under tension. The sudden inertial shove eastward would be much stronger than the mortar holding the bricks, so buildings would rip apart. Homes, bridges, and towers would crumble or be carried off by winds and floods. Vehicles and unsecured objects would slam violently into one another or be thrown into the air. Most people outside a very small polar zone would not survive the initial moments. According to Business Insider, near the poles within approximately 7 miles of the true pole, the rotational speed is negligible, so someone standing there might only be knocked over at walking speed. Even so, beyond that tiny region, everyone would be hurtled along. A person might be pinned by wind, crushed by debris, or thrown into the ocean. In fact, the vast majority of humans who live far from the poles would still go flying at hundreds of miles an hour. Wildlife would likewise be decimated. Perhaps only some deep sea or polar life could momentarily avoid destruction. The net result is near total collapse of civilization and mass extinction of life. Earth's magnetic field and radiation. A lesser-known consequence is the collapse of Earth's magnetic field. Our geomagnetic field arises from the jadonamo, swirling molten iron in the outer core driven by Earth's rotation. NASA explains that nearly all of Earth's magnetic field is generated by convection in the fluid outer core, as molten metals swirl in whirlpools driven by Earth's rotation. If the spin stopped, this dynamo would shut down. Within years to centuries, the magnetic field would decay. Without it, Earth would be exposed to intense solar and cosmic radiation. The magnetic shield protects us from the charged particles of the solar wind and cosmic rays. Losing it would strip away the atmosphere and irradiate the surface, as happened on Mars eons ago. In short, life on Earth would become impossible in the long run due to radiation poisoning. Rewriting day, night, and climate. If Earth were magically stationary yet still orbiting the Sun, one full day would stretch the length of a year. In practical terms, 6 months of daylight would alternate with 6 months of night. Business Insider and SciFocus both emphasize this. As Levy notes, instead of 24-hour days, a single sunrise to sunrise period would last about half a year. During 6 months of day, intense solar heating would scorch continents, roasting crops and boiling seas. Then 6 months of night would freeze everything solid. Such extremes would make agriculture impossible. Even before the stop, crops would fail under constant sun, and plants would die in extended darkness. Only a narrow zone near the limb between day and night might see moderate sunlight at low angles. But it's doubtful this band could sustain anything beyond primitive life for more than a short while. Moreover, the lack of rotation would tear up our weather systems. On today's Earth, solar energy is distributed by spinning air masses and the Coriolis effect. Without that, global circulation collapses into brutal polar jets. A new kind of wind belt would form along the sunrise/sunset line, the Terminator, whipping air across from the hot side to the cold side. Weather patterns would be unpredictable and violent, a mix of permanent storms and stagnation zones. Clouds might freeze out completely over the dark half and boil away on the sunny half. In all, life would have to become literally migratory, as BI suggests, or else perish. If Earth stopped orbiting the Sun. For completeness, consider if Earth's motion around the Sun suddenly ceased. In that case, gravity would immediately pull Earth straight inward. As Cambridge astronomer Carolyn Crawford explains, with no orbital motion, there's nothing left for it to do other than to fall straight into the Sun. Earth would then spiral inward, reaching Mercury's orbit in a matter of months. The heating from the Sun would become catastrophically high. Temperatures would soar to thousands of degrees Celsius, far beyond rock's melting point. Tidal forces from the Sun would stretch and compress the planet, eventually tearing it apart. In short, Earth and everything on it would be incinerated and disintegrated by the Sun's gravity. Thankfully, like a sudden spin stoppage, this scenario is essentially impossible without a cataclysmic event. It's purely hypothetical. How likely is any of this? All these horrors sound like a disaster movie plot, and indeed, no planet in our experience behaves this way. Experts emphasize that Earth has no reason to stop rotating or orbiting on its own. Reassures us that it is very unlikely that Earth will ever stop rotating, scientists say. The planets and Sun formed from a spinning disk of debris, so almost every planet inherited rotation. To stop Earth, a truly massive impact planet-sized would be needed, which would itself be unsurvivable. Even the Moon's gentle tidal drag only slows Earth's spin by about 2.3 milliseconds per century, a tiny effect. In short, none of these catastrophes will occur in reality. Summary. In summary, if Earth were to magically stop turning, the initial moments would be utterly devastating. Everything not nailed down, people, objects, oceans, air would be flung eastward at high speed, causing global tsunamis, earthquakes, and hurricane-force winds. Buildings and forests would be obliterated. Most life outside a tiny polar zone would be killed instantly. In the longer term, one hemisphere baking under 6 months of unending sun, and the other freezing in darkness would make the planet unlivable. Our magnetic field would fade without rotation, exposing us to deadly radiation. If instead Earth stopped orbiting, we'd plunge into the Sun in a matter of months. In reality, nothing like this will happen. It's a fascinating thought experiment only. All the same, it underscores how the motions of our planet protect life. Without spinning and orbiting smoothly, Earth would become a wasteland. Sources: we based these scenarios on physics and expert accounts from Smithsonian Magazine, BBC Science Focus, NASA, and other scientific sources, which describe the catastrophic effects of a sudden stop in Earth's spin or orbit. What if Earth suddenly stopped rotating? Imagine looking up at the night sky and seeing stars streaking overhead in long trails. A long exposure photo of the sky shows this because Earth is spinning. In reality, we don't feel this motion at all. At the equator, the ground moves around at about 1,000 miles per hour, 1,600 kilometers/h, yet everything on Earth moves together. Gravity simply holds us and the air down as the planet turns, so we feel perfectly still. But what if, by some unimaginable force, our spinning world came to an abrupt halt? Suddenly stopping Earth's rotation would trigger immediate, global cataclysms. Inertia would fling everything eastward at top speed. For example, at the equator, people, buildings, and loose objects would keep moving at approximately 1,000 mph, even as the ground stopped beneath them. In practical terms, this means people and animals would be thrown violently off their feet. The momentum would rip trees and structures from the ground, and whole cities could be swept away like debris. Meanwhile, the oceans would surge eastward into continent-spanning megatsunamis. Coasts everywhere would be obliterated. Imagine waves hundreds of feet tall smashing over entire countries. The atmosphere itself, still spinning, would drive unimaginably fast winds faster than any hurricane, literally scouring and flattening the landscape. In short, the first moments after a stop would see the planet racked by devastating earthquakes, global tidal waves, and supersonic windstorms as everything not solidly bolted down keeps moving due to its inertia, even near the poles, where ground speed is near zero. The shock waves from these massive quakes and tsunamis would still pound the ice caps and polar regions. No part of the world would be safe. Objects and people flung eastward. At the equator, Earth's spin gives a sideways speed approximately 1,600 kilometers/h. If Earth stops, everything not anchored, people, cars, trees, even oceans would keep moving at that speed. Megaquakes and tsunamis. The sudden deceleration of land and water would trigger planet-wide earthquakes and colossal tsunamis within minutes. Atmospheric superstorms. The high-speed winds would strip forests and soil, essentially turning the atmosphere into a giant planet-wide hurricane. Polar exception barely. Polar regions rotate slowly now, so things would feel slightly less violent up north/south. But even there, the global shockquakes, ice sheet fractures, tidal surges would be catastrophic. Technology and daily life collapses. Beyond natural disasters, our technology and daily rhythms would implode. Satellites in orbit would fail, crippling communication and navigation. Most communication satellites are placed in geostationary orbit. They circle Earth once per day to stay above a fixed spot. If Earth stops spinning, those satellites would no longer stay above the same ground point and would drift away. We'd instantly lose TV, internet, GPS, weather monitoring, essentially all satellite services. Day and night cycles would vanish as we know them. With no rotation, Earth would still circle the sun once per year, but would no longer spin daily. That means one day would stretch to a full year. Each side of Earth would spend about 6 months in daylight and 6 months in darkness. Think of the North Pole experiencing half a year of continuous day, followed by half a year of night, but on a global scale. Our 24-hour clocks and human circadian rhythms would be shattered. We'd have prolonged twilight and no normal sunrise/sunset. The sun would creep across the sky only once a year, never rising or setting fast as now. Satellite networks fail. Geostationary satellites rely on Earth's one-day spin to stay fixed over one spot. If that spin stops, satellites drift out of position, knocking out TV, phone, GPS, and all satellite-based infrastructure. Altered day-night cycle. Days would last 6 months of daylight, followed by 6 months of night. This would severely disrupt life, as our clocks, sleep cycles, and growing seasons all depend on 24-hour days. Extreme seasons. Locations along the equator would endure brutal climate swings, for months baking under constant sun, then for months freezing in darkness. Even moderate climates like ours would become severe, one half year of scorching heat, the other of deep cold. The poles already seeing long polar days would see the same, but shifted by geography. A new Earth geography. Without rotation, Earth's shape and oceans would reshape completely. Right now, centrifugal force makes our planet bulge at the equator. It's slightly wider around the middle. If the spin stops, this bulge disappears. The loose seawater currently piled up along the equator would rush toward the poles under gravity. In computer models, all the equatorial oceans flood to form huge polar seas, and the continents become one giant equatorial supercontinent. Imagine Earth with one wet polar cap and another, and dry land circling the new equator. The familiar shapes of continents and oceans would vanish in days. Over longer timescales, gravity would feel a bit stronger at the old equator. Right now, rotation slightly counteracts gravity at the equator. Without it, weight effectively increases there. Mountains might grow taller, and sea level would seem higher at mid-latitudes as water shifts. In short, geography and climate belts would be completely redrawn. No equatorial bulge. With no spin, Earth would become a true sphere instead of squashed. All that extra water at the equator would flood away. Polar oceans, equatorial continent. Models show the Arctic and Antarctic oceans expanding massively. In effect, a giant ring of land would form along today's tropics, a new supercontinent, surrounded by northern and southern polar seas. Changed gravity. People at the former equator would feel a slightly stronger pull. Earth's centrifugal spin lift is gone, altering everything from ocean tides to how tall mountains appear. Magnetic field and radiation. Earth's protective magnetic field is tied to its rotation. The spinning liquid iron in our core drives a geodynamo that keeps the magnetic field alive. If the planet stops rotating, the core's convection would slow and the geodynamo would weaken over time. In centuries or millennia, the magnetic field could collapse altogether. Without this shield, the planet's surface would be exposed to the full brunt of solar winds and cosmic rays. We would see global auroras, and high-energy radiation would penetrate to ground level. Electronics and power grids already down from the satellites would face massive surges from space weather. In effect, planets like Mars lost their atmospheres when their fields died. Earth could face similar risks if the spin stops. Magnetic shield vanishes. The geodynamo requires rotation. Without spin, core currents fade, and the magnetic field would decay. Radiation hazards. With no magnetic field, solar and cosmic radiation would bombard the surface. Life, especially near the dark side or poles, would receive lethal radiation doses. Even electronics and remaining power systems would be destroyed by intense space weather. Biosphere collapse. Life on Earth depends on the cycle of day and night and on stable climates. In this new world, ecosystems would almost entirely collapse. The sunlit side of Earth would become an unrelenting desert under constant heat. The dark side would freeze solid. Plants which need sunlight would die on the night side, and the day side would be scorched by unrelenting midday sun. As the BBC Sky at Night summary warns, life forms that photosynthesize would die out on the dark side and life on Earth would therefore suffer a mass extinction. Only a narrow twilight zone between perpetual day and night might offer any livable conditions. Animals and humans, if any survived the initial shock, would struggle. Crops would fail, food chains would break, and fresh water would freeze or evaporate. In short, humanity would face the end of the world as we know it. Centuries or millennia later, the Earth would be tidally locked with the sun, one hemisphere baking in eternal sunlight, the other frozen in darkness. Under these conditions, all life on the dark side would vanish, and even the lit side would be a blazing wasteland. Only the narrow ring of perpetual sunset between light and dark might remain barely habitable, but even that would be precarious. Is this possible? Fortunately, this nightmarish scenario is purely hypothetical. There is no known force that could instantly halt Earth's spin. The energy locked in our planet's rotation is enormous, equivalent to billions of nuclear bombs. As Smithsonian experts point out, no natural mechanism on or off Earth could supply that momentum in one go. In fact, Earth's rotation is slowing only by about 1.7 milliseconds per century due to tidal effects, a change so slight that days lengthen by roughly 1 second every 50,000 years. Every planet spins, and the solar system itself formed from a swirling disk of dust. So it is very unlikely that Earth will ever stop rotating on its own. In other words, while the consequences outlined above are dramatic, they remain in the realm of science fiction. No sudden break. Stopping Earth's rotation would require an impossibly large torque. In practice, our planet's spin will only ever decelerate extremely slowly over billions of years due to tidal friction. Astronomical consistency. Every planet and star we observe still spins. It's a fundamental outcome of how celestial bodies form. We can safely say we won't see Earth freeze its spin anytime soon. Key takeaways: global cataclysm, instant stop =, everything not solid flies east, megaquakes, tsunamis, and superstorms devastate the planet. Technology blackout. All geostationary satellites and long-term infrastructure fail immediately. Day-night upended. Days become approximately 6 months long. Equatorial regions face horrific heat/cold swings. Geography reshaped. Oceans migrate to poles, creating giant polar seas and a continuous equatorial landmass. Magnetic loss. Earth's protective magnetism would weaken over time, letting cosmic rays strike the surface. Mass extinctions. Life would almost entirely collapse, as plant/animal ecosystems can't survive perpetual light or dark. Science says don't panic. No physical process can do this. Earth's rotation is safely continuing as always. While the scenario is fascinating and terrifying to consider, it remains purely theoretical. Our research, backed by astronomers and planetary scientists, consistently shows that a sudden stop of Earth's rotation would be truly apocalyptic. Sources: reputable science and space publications, Smithsonian Magazine, Sky and Telescope, How Stuff Works, and expert analyses were used to compile these insights. Each statement above is grounded in scientific studies and expert commentary. What would happen if the Earth suddenly stopped? Imagine a startling scenario: the Earth, spinning at about 1,000 miles per hour, 1,600 kilometers/h at the equator, suddenly comes to a halt. We don't feel our daily spin because everything, ground, air, people, moves together at constant velocity. But if that spin ceased, physics tells us the consequences would be catastrophic. In an instant, all objects not firmly anchored to bedrock, from oceans and cars to people and buildings, would keep moving eastward at that speed. Scientists predict a chain reaction of disasters. In a flash, the crust and oceans would surge, unleashing global earthquakes, mega tsunamis, and atmospheric superstorms. In reality, experts note no force can stop Earth's spin. Jim Zimbelman of the Smithsonian Institution calculates that no physical mechanism on Earth can supply the immense energy required. For fun, we'll step through what would happen if this impossible event occurred. Catastrophic initial effects. Objects hurled at 1,000 miles per hour. At the equator, the Earth's surface is moving approximately 1,000 mph 1,600 km/h. If rotation stops suddenly, that momentum would launch everything eastward at high speed. Humans, animals, cars, trees, anything not sunk into solid rock, would be swept away as if by a colossal tsunami. Global earthquakes and tsunamis. The sudden inertial forces on Earth's crust would literally rip continents apart. Geologists predict massive quakes worldwide and enormous tidal waves as land and ocean basins slosh violently. Coastal cities would vanish under monster tsunamis, and the very shape of continents might change. Incredibly strong winds. The atmosphere would keep spinning while the ground stops, producing unimaginable wind speeds. One NASA scientist describes the day-night terminator, the border between permanent day and night, as becoming very, very windy. Every region would be battered by hurricane force or stronger winds that scour the land and erase familiar landscapes. The day-night cycle turns to a year. In this new world, a day-night cycle would stretch to the length of a year. With no rotation, the sun would hang fixed in the sky. Each place on Earth would face half a year of continuous daylight, followed by half a year of darkness. Along the equator, folks would endure months of blazing sun as the Earth stood still, then months of freezing night when that spot faced away from the sun. Think of living at the North Pole, but worse. Instead of 6 months day and 6 months night, it would happen everywhere. These extreme cycles would destroy normal seasons. Food crops and ecosystems adapted to daily rhythms would collapse when suddenly forced into month-long heat or cold. Circadian rhythms, our body clocks, would be broken, and the very concepts of day and night would be meaningless. Oceans and land reshape the planet. Without spin, the Earth's equatorial bulge disappears and water redistributes toward the poles. Currently, centrifugal force makes Earth slightly fatter at the equator. Once that force vanishes, water stored in the bulge rains down toward higher latitudes. Models show gigantic floods reshaping coastlines. Most equatorial areas sink underwater, while land rises near the poles. In fact, geographers predict one continuous supercontinent circling the new equator, with 2 massive polar oceans. Islands and current continental layouts would be unrecognizable. The flooded equator might leave the tropics under hundreds of feet of water, submerging many current cities and nations. Chaos in the atmosphere and weather. Earth's rotation drives wind and weather systems through the Coriolis effect. If the spin stops, global circulation collapses. Large-scale wind patterns that normally redistribute heat between the equator and the poles would break down. Without the Coriolis effect, storms would no longer spiral in predictable ways. Instead, the climate boundary between the day and night hemispheres would become extremely turbulent and windy. In short, the entire climate system would be thrown into chaos. The fixed hemispheres would heat and cool unevenly. The sunlit half would become extremely hot over months, while the dark half would plunge to frigid temperatures. Atmospheric convection would generate violent winds flowing from the hot side toward the cold side. A similar effect is seen on Venus, where slow rotation still produces intense jet stream winds because one side is constantly heated. One could expect never-ending superstorms along the boundary of sunrise and sunset. Satellites, magnetic shield, and technology. Everyday technology would begin to fail. Communications and GPS satellites in geosynchronous orbit would lose their ability to remain fixed above the equator if Earth stopped spinning. Power grids and time-keeping systems, which depend on a 24-hour cycle, would be disrupted. Even worse, Earth's magnetic field, generated by the motion of molten iron in the core, would gradually weaken without rotation. Over years to centuries, the protective magnetosphere would fade and eventually disappear. Without this shield, harmful solar and cosmic radiation would bombard the surface, much like what happened on Mars when it lost its magnetic field. The planet would lose the invisible armor that protects its atmosphere and life. Life on a stopped Earth. The ultimate victims would be Earth's ecosystems. Plants and animals are precisely adapted to our day-night cycle and stable climates. In unending sunlight, life on the bright side would burn or overheat, while the perpetual night of the dark side would cause life to freeze and die. Photosynthetic organisms on the dark half would not survive, crops would fail, food chains would collapse, and most species could face extinction. Only small pockets of life might persist in a narrow twilight band between the overheated and frozen halves. Yet even there, storms and climate conditions would be extreme. Humans would struggle as farmland disappeared beneath rising seas or blizzards. Infrastructure failed under storms and seismic shifts, and global economies, built on stable cycles, collapsed. Some technologically advanced regions might survive in sealed artificial environments, but the planet as a whole would become hostile and nearly lifeless. Why? This can't really happen. Fortunately, Earth cannot simply stop spinning. The amount of rotational energy stored in the planet is enormous, far beyond what any explosion or impact could counteract. Even if some hypothetical force gradually slowed the rotation, the process would still cause catastrophic earthquakes, flooding, and global restructuring as the planet adjusted to a new shape. Ultimately, this scenario remains purely a scientific thought experiment. Summary: if Earth somehow did stop spinning, the consequences would be unimaginably severe. People at the equator would be hurled forward. Oceans would overwhelm coastlines. Winds would ravage the planet. And one half of the world would become scorching hot while the other froze solid. By the time the planet settled into a year-long day-night cycle, only the toughest forms of life, if any, might survive. The world would be unrecognizable. Fortunately, no natural mechanism can halt Earth's rotation, so the planet will continue spinning safely, giving us the steady rhythm of day and night. Sources: this scenario is pieced together from scientific sources and expert analyses, Smithsonian Magazine, How Stuff Works, Britannica, etc., that explore the consequences of a stopped Earth. What would happen if the Earth suddenly stopped? Imagine waking up to a world where our planet has suddenly stopped spinning. On Earth, a full rotation takes about 24 hours, so every point on the equator is moving eastward at roughly 1,600 kilometers per hour, about 1,000 miles per hour. We don't feel this motion in everyday life, but it's enormous. If Earth's spin were to abruptly halt, all that inertia would fling everything not anchored down across the surface. In short, the effects would be catastrophic, a complete one-time transformation of our planet. Objects launched by inertia. Because of inertia, everything, cars, furniture, buildings, even the air, would keep moving eastward at Earth's former rotational speed. At the equator, a person would suddenly be launched at over 1,000 miles per hour if they weren't strapped down. Scientists note that objects, and even the atmosphere, would continue their motion, essentially separating from the surface, with some debris briefly reaching low orbit before falling back. Supersonic winds and atmospheric surge. The atmosphere would not stop instantly either. Unmoored air would convert into hurricane force, and even supersonic winds that would scour the surface. These winds would obliterate buildings, forests, and soil, ripping landscapes clean. Mega tsunamis and earthquakes. the abrupt stop would place extreme stress on the crust. Oceans and rivers, still moving by momentum, would surge onto land. Massive tsunamis and quakes would tear across the planet. Moving rocks and water would trigger devastating seismic activity and towering waves. Coastlines would be wiped out, and fault lines would rupture violently, shattering of the surface. The planet's outer shell would effectively be torn apart. The sudden release of angular momentum could rip large sections of crust free, launching them into the sky. Some analyses describe chunks of the surface breaking off and being hurled into the upper atmosphere or even into space as the ground shears under the force. Molten aftermath. As debris rained back down, Earth's gravity would pull the fragments together again, but the impact would release enormous heat. It would be comparable to millions of meteor strikes occurring at once. This bombardment would melt much of the crust into a global ocean of magma. The planet would end up covered in a scorching molten sea. Water vaporization. Most of Earth's surface water would vaporize during this molten phase. Oceans and ice would turn into steam, thickening the atmosphere temporarily. Some of the vapor would escape into space, while the rest would become trapped within newly formed rocks. The final result would be a hot, dry planet reshaped by heat and collision. In summary, a sudden halt of Earth's rotation would completely annihilate the biosphere. Trees, animals, and humans would be crushed, burned, or thrown off the planet long before they had any chance to respond. No life could survive the initial event. It would be a planet-wide extinction scenario. Long-term changes. If the planet somehow survived. If Earth somehow remained intact as a planet after the catastrophe, its environment would be drastically different. Even ignoring the initial destruction, the new world would be harsh and unrecognizable. Extreme day/night cycle. Without rotation, the sun would appear fixed in the sky. One side of Earth would endure perpetual daylight, while the opposite side remained in constant night, except for the slow change as Earth orbits the sun. If Earth stopped gradually, days and nights would eventually stretch to 6 months each. In practice, every location would alternate between half a year of continuous sunlight and half a year of darkness, similar to the conditions at today's poles. Temperatures would swing from scorching heat to extreme cold in ways no ecosystem could survive. Equatorial regions would roast for months, while the opposite side would freeze solid. Reconfigured oceans and continents. Earth's shape would change without the centrifugal bulge at the equator. When this bulge disappeared, the vast amount of water now held around the equator would rush toward the poles. Massive polar oceans would form, flooding high-latitude regions. Meanwhile, equatorial waters would drain away, exposing a huge new landmass circling the globe. Models predict that Earth would become one enormous equatorial supercontinent separating two hemispherical seas. Imagine a continuous ring of land around today's tropics, with two giant polar oceans instead of our current arrangement, altered seasons and climate. Seasons would still exist due to Earth's axial tilt, but they would become far more extreme. The sunlit side would bake for months, then freeze when darkness arrived. Winds and weather patterns would reorganize completely. Without rotation-driven jet streams and trade winds, the global climate system would collapse. Temperate zones would shift dramatically or disappear altogether. The climate would become almost unrecognizable, with permanent scorched regions and perpetually frozen areas. Magnetic field collapse. One of the most critical long-term effects would involve Earth's magnetic field. The magnetic shield is generated by convection currents in the molten iron core combined with Earth's spin. Without rotation, these currents would weaken significantly. Over thousands to millions of years, the magnetic field would fade away. Once the magnetosphere weakened, solar and cosmic radiation would strike the atmosphere directly, eroding it. This is similar to what happened on Mars when it lost its magnetic field. Its atmosphere was stripped away, leaving a barren, frozen world. Earth could face a similar fate over long timescales, making the survival of life even less likely. Could Earth ever stop spinning? Nothing on Earth can stop its rotation on its own. A spinning object keeps spinning unless acted upon by an enormous external force. There is no natural mechanism capable of halting Earth's rotation suddenly. All planets and stars rotate because they inherited their spin during formation, and only a colossal impact far larger than anything in recent geological history could significantly change that speed. It is extraordinarily unlikely that Earth would ever come to a sudden stop. If such a collision did occur, for example, if a planet-sized body struck Earth, the consequences would be far beyond any disaster described here, and humanity would not survive long enough to notice whether the rotation stopped or not. Fortunately, no event of that scale is expected. Our day-night cycle will continue undisturbed for the foreseeable future. In conclusion, if Earth somehow really stopped rotating, the immediate effects would be apocalyptic. Everyone and everything flying eastward, world-spanning earthquakes and tsunamis, and the landscape scoured by supersonic winds. The ensuing aftermath would leave a molten, reshaped planet with an ice-covered dark side and a roasted bright side. Long-term, the planet's magnetic field would collapse, leaving it unprotected against space radiation. While this scenario makes for a fascinating thought experiment and a dramatic video topic, official science sources agree it will never actually happen. Earth will keep spinning, and life on it will hopefully keep going as usual. Sources: all information above is drawn from reputable science publications and experts. Each fact is supported by one or more of these expert sources. What would happen? If the Earth suddenly stopped rotating, imagine waking up one morning to find that our planet's spin has come to a halt. Earth currently rotates at about 1,667 kilometers/h1036 miles per hour at the equator, yet we never feel this motion because everything around us moves together under gravity. If that rotation were to magically stop, the consequences would be immediate and catastrophic. Immediate catastrophe. Inertia unleashed. If Earth's rotation stopped abruptly, inertia would continue to propel everything not firmly attached to the surface. People, buildings, vehicles, almost everything would be hurled eastward at the tremendous speed Earth had been spinning. At the equator, that speed is about 1,667 kilometers/h, enough to flatten entire cities and throw objects vast distances. The ground itself would seem to lurch violently, as though the planet had slammed on the brakes. The sudden stop would also trigger worldwide geological chaos. The deceleration of this magnitude would tilt the sensation of down significantly, causing structures to topple. Massive stresses would fracture roads, tear apart buildings, and likely set off enormous earthquakes and tsunamis. Ocean waters would surge as the crust shifted, producing colossal waves racing across entire ocean basins. An instantaneous halt would devastate Earth's surface almost immediately. Atmosphere and oceans in motion. Earth's atmosphere also carries enormous momentum. If the planet stopped, the air would keep moving. This would generate winds far stronger than any hurricane, supersonic gusts capable of leveling forests and cities alike. Meanwhile, the oceans would rush toward the poles. Without the centrifugal force created by rotation, the equatorial bulge of water would vanish. Vast amounts of water would migrate north and south, causing sea levels at the equator to drop dramatically and forming two enormous polar oceans. Huge areas around the equator would become exposed land, while many regions closer to the poles would be submerged. Slowing down gradually, longer days and climate chaos. Even if the Earth slowed gradually instead of stopping instantly, the consequences would still be severe. days would grow longer as rotation slowed. Eventually, the planet could take an entire year to rotate once, creating 6 months of daylight followed by 6 months of night, similar to polar regions today, but affecting the whole world. Climate systems would be thrown into turmoil. The Coriolis effect, which drives wind and ocean currents, would weaken and eventually disappear. Weather patterns would collapse or reorganize into extreme and unpredictable systems. Familiar seasons would vanish, replaced by chaotic climate behavior. A new geography, polar oceans, and an equatorial supercontinent. Without rotation, Earth would gradually reshape itself. The equatorial bulge would disappear, and water currently held there by centrifugal force would flow toward the poles. This would create 2 vast polar oceans and a giant land belt encircling the equator. Continents would shift in appearance dramatically, coastlines would be redrawn, and recognizable geographic features would be transformed beyond recognition. Eternal day vs. eternal night. Over time, the planet would become tidally locked with the sun, presenting the same side permanently. One hemisphere would experience eternal daylight, while the other would remain in perpetual darkness. The sunlit side would be scorched under unending radiation. Temperatures could climb well above 100 degrees Celsius, evaporating rivers, lakes, and even shallow seas. The atmosphere would become blisteringly hot. The dark side would become a frozen wasteland. In 6 months of darkness, temperatures would plummet to extreme lows. Moisture in the air would freeze out, forming a massive ice cap. Photosynthetic life on the dark side would die out entirely, collapsing ecosystems. Only a narrow region along the terminator, the line between day and night, might remain somewhat habitable. Magnetic field and satellites. Earth's magnetic field is generated by the motion of molten iron in the core, which is influenced by rotation. Without rotation, this dynamo would weaken over time, causing the magnetic field to gradually collapse. Over thousands of years, Earth could lose most of its protective magnetosphere, exposing the surface to harmful solar and cosmic radiation. Modern technology would also suffer catastrophic failure. Many satellites depend on Earth's rotation, such as geostationary satellites that hover above the same point on the equator. If Earth stopped spinning, these satellites would drift out of position, disrupting communications, GPS, and weather monitoring systems worldwide. Summary of key consequences. Extreme inertia. Everything not firmly attached would be thrown eastward at approximately 1,667 km/h. Buildings would collapse, and massive earthquakes would be triggered. Violent winds and tsunamis. Supersonic winds and immense tsunamis would sweep the world as the atmosphere and oceans adjust. Long days and nights. Days would gradually lengthen until they last 6 months each, disrupting all biological rhythms. Permanent day/night. Eventually, one side of Earth would burn in endless sunlight, while the other would freeze in eternal night. Magnetic shield lost. The magnetic field would weaken and potentially collapse, leaving Earth exposed to radiation. Technological collapse. Geostationary satellites would stop functioning, breaking crucial communication and navigation systems. Biological collapse. Photosynthetic life would die on the dark side, causing widespread ecosystem failure. Survival on a motionless Earth. Next segment. Humanity would quickly learn that life on a non-rotating Earth isn't just a test of strength. It's a test of imagination. And those who survived the initial catastrophe would face a question no generation before them ever had to answer. How do you rebuild a world that no longer moves? 1. The narrow belt of life. As centuries passed, the surviving populations slowly concentrated around a single habitable band, a thin twilight region where the sun always hovered close to the horizon. Here, the air was cool enough to breathe, but not cold enough to freeze. Warm winds drifted from the dayside, icy gusts from the night side, constantly mixing into a temperamental but survivable climate. Communities formed wherever the ground allowed construction, often along natural windbreaks such as mountain ranges or canyon systems. They carved settlements into cliffs, built underground chambers, and created skylight tunnels that captured the soft, permanent glow of the horizon. To them, sunsets and sunrises were not brief moments, they were the entire sky. Eternal, unmoving, silent. 2. Agriculture in the twilight. Growing food required ingenuity. Traditional farming died with the old earth, but humans adapted. They developed subsurface farms insulated against extreme cold and heat. Hydroponic systems powered by wind turbines that never stopped spinning. Solar towers placed slightly closer to the dayside, capturing constant sunlight. Every settlement had a light harvest team, groups who traveled a few kilometers toward the dayside to gather energy and return before the temperatures became unbearable. Seeds were treasured like ancient relics. Every sprout, every leaf, every successful harvest was celebrated with ceremonies that blended gratitude and superstition. Plants became symbols of survival itself. 3. Water, the hardest challenge. Even in the twilight belt, water was scarce. The atmosphere behaved differently now, forming strange circulation patterns. Rainfall was unpredictable. Rivers froze on one side of the world and evaporated on the other. The survivors built towering condensation collectors, harvesting moisture from constant winds. Underground lakes became sacred. Whole communities were built around them, protected by strict laws and shared responsibility. Water theft became the most serious crime, one that could exile a person into either the burning dayside or the frozen night. 4. The weight of eternal light and eternal darkness. Psychologically, the New World imposed an enormous burden on the human mind. Generations grew up without experiencing night's calm or day's vitality. The sky remained a single gradient of gold, purple, and faint blue that never changed. Children born into this world had no concept of time the way their ancestors once understood it. Days, seasons, and years lost their meaning. Instead, people began measuring time by wind cycles, temperature fluctuations, or shifts in cloud patterns. Some communities invented new forms of art to cope with the monotony. They painted enormous murals on the insides of caverns, using pigments mixed from minerals of the dark side. They created musical traditions based on the sound of wind passing through geological formations. They crafted stories of the world that once moved, which to many sounded more like myth than history. 5. Myths of the spinning Earth. Over generations, the story of the rotating Earth became legend. Some believed the planet had once danced in the sky. Others thought ancient humans exaggerated their tales to entertain children. Only a few scholars maintained records of old physics, preserving dusty books and digital files powered by wind and geothermal energy. To the children born centuries after the stop, the idea of a rising sun was almost impossible to visualize. Elders would tell them, "There was a time when the sun traveled across the sky. There was morning, noon, evening, and night." And the children would laugh, unable to imagine such magic. 6. Technology in a forgotten world. Humanity's technological advancement took an unexpected turn. Instead of growing outward with satellites, global transportation, and massive power grids, innovation focused on survival within a narrow band of existence. Key technologies included wind-driven generators, as winds between day and night were powerful and constant. Geothermal stations, built near tectonic hotspots. Biological recycling systems, allowing communities to reuse nearly every molecule of water and organic matter. atmospheric filters, protecting against harsh solar radiation and volatile chemicals from the overheated dayside. Despite limited resources, knowledge became humanity's most valuable currency. Libraries were carved into rock. Archives were guarded, and every child grew up learning engineering, biology, and the history of the world that once spun. 7. 1,000 years later. After a millennium of adaptation, humans no longer looked or thought exactly like their ancestors. Their bodies became slightly broader or leaner depending on which side of the twilight they lived on. Some developed denser bone structures from underground living. Their eyes adapted to the eternal dim light, capable of seeing subtle color variations that old humanity would have missed. Their culture unified around two themes: gratitude for survival and fear of the unknown beyond the twilight belt. Travelers spoke of monstrous storms on the dayside and glaciers hundreds of kilometers high on the night side. Expeditions were rare and dangerous, but every few generations, a group would attempt to push the boundaries. Scientists, explorers, dreamers. Some never returned. 8. Humanity's future on a still Earth. 10,000 years after the stop, humanity became a species shaped entirely by a motionless world. The twilight zone transformed into a ribbon of cities, stretching like a luminous necklace around the planet. Trade caravans moved along this great ring, carrying seeds, minerals, and stories. Wars became rare. Territory was limited, and interdependence was the only path to survival. And slowly, humanity found peace in the unchanging horizon. 9. 1,000,000 years later. If humanity endured that long, it would be almost unrecognizable. The still Earth would sculpt new species, new forms of intelligence, and ecosystems adapted to a static world. Maybe humans would harness geothermal planet-scale energy. Maybe they would evolve into nocturnal or low-light beings. Maybe they would finally explore the deadly dayside with advanced suits or machines. Or perhaps, one day, they would attempt the impossible, ignite massive engines, harness the momentum of celestial objects, and try to make Earth spin again. But that is a story for another world. Segment 6. The Earth that no longer turns. When Earth stopped spinning, humanity faced the immediate shock. But the planet itself also began a long, slow transformation, a reshaping not in days or years, but in epochs. Landscapes twisted, oceans migrated, atmospheres learned new rhythms. If you could stand on this still Earth for 10,000, 100,000, or 1,000,000 years, you would witness a world almost alien, sculpted by a sun that never moves. Let's return to that future. Let's watch the planet rewrite itself. 1. The oceans begin their long march. In the first centuries after the stop, Earth's oceans shifted toward the poles under the pull of gravity. Water accumulated into two massive superoceans, leaving the equatorial regions increasingly dry. But this was just the beginning. Over thousands of years, coastlines collapsed or expanded into new forms. Former seabeds turned into desert plains, and deeper ocean trenches became colossal freshwater reservoirs fed by ancient glaciers. Near the dayside, the oceans evaporated faster than rivers could replenish them. What remained was an immense basin of boiling mist and salt flats that stretched farther than any desert humanity had ever known. This landscape shimmered under the unmoving sun, a blinding mirror of white salt and twisted mineral formations. On the night side, the oceans froze into mountain ranges of ice. These weren't just sheets of frozen water. They were continents of solid, blue-black ice, thicker than the Himalayas. Crevasses glowed with ethereal pale light, illuminated by trapped atmospheric gases and faint bioluminescence from creatures that adapted to the eternal dark. Two different worlds tethered to the same planet. 2. Continents in slow motion, Without the stabilizing effect of rotation, tectonic plates behaved differently. They still drifted, but patterns changed. The day side expanded from thermal stress, forming wide cracks and volcanic ridges. The night side contracted from intense cooling, pushing crustal layers together into vast mountain chains. The twilight belt experienced violent tectonic collisions, earthquakes, and the birth of new ranges that scarred the horizon. Over tens of thousands of years, the continents reshaped into something almost unrecognizable. A blistered, scorched supercontinent under eternal daylight. Two frozen continental shields locked in unending winter, and a broken ring of habitable land squeezed between extremes. This ring, the Twilight Ring, became the heart of all life. Its mountains shielded settlements from the worst storms, and its valleys captured just enough warmth to sustain liquid water. But the planet was still changing. 3. The atmosphere adapts to eternal stillness. The atmosphere evolved in ways old humanity could never have predicted. On the day side, superheated air rose constantly, creating an enormous vertical plume stretching hundreds of kilometers into the sky. Dust, sand, and ash spiraled upward in golden storms that never stopped. Wind patterns formed colossal circular hurricanes, locked in place like atmospheric scars. On the night side, cold air collapsed toward the ground, pooling like black water. Gigantic sheets of frigid air would occasionally slide toward the twilight belt, causing sudden deadly temperature drops. These events were known to survivors as falls, as if the night itself tried to break into their world. In the twilight zone, winds circled the globe in a continuous jet stream. This became both a blessing and curse. It allowed for wind energy but created weather so unpredictable that settlements needed layered defenses. Thunderstorms spawned lightning arcs, lasting minutes at a time, dancing across the sky like glowing webs. Rain came suddenly, violently, and left just as fast. Earth's atmosphere had entered its own strange equilibrium. 4. Life evolves in the twilight. After the stop, most species perished. But life is persistent, and it adapted. Plants in the twilight zone evolved to survive dim, constant light. Some developed reflective leaves to gather the maximum glow from the horizon. Others burrowed deeper underground, tapping geothermal heat. Their colors shifted toward deep purples and blues, allowing them to absorb wavelengths of light that humans once couldn't even see. Animals changed as well. New species emerged. Fur-covered grazers that could tolerate rapid temperature swings. Predators with enlarged eyes adapted to permanent dusk. Insect-like creatures powered by geothermal vents. Amphibious scavengers living near condensation fields. But the most extraordinary developments occurred on the night side. In total darkness, life began to mimic deep ocean ecosystems from old Earth. Entire food chains formed around geothermal heat. Strange, translucent creatures glided through icy caverns. Massive fungal forests grew beneath the ice, glowing faintly like underwater stars. Far beneath the frozen crust, water still flowed in heated rivers, warm enough for life to thrive, hidden from humanity's sight. On the day side, meanwhile, nothing survived except microbial extremophiles, tiny architects slowly transforming minerals, feeding on heat and leaving behind intricate patterns on the scorched ground. The planet was alive in its extremes. 5. Stormscapes and planet-wide weather engines. Over millennia, storms on the still Earth became legendary. On the day side, perpetual solar heating created cyclones thousands of kilometers wide. These were not storms as humans once knew them. They were continent-sized turbines of fire and dust, their eyes shimmering like molten gold. They moved slowly, grinding the landscape beneath them. On the night side, frozen superstorms swept across ice plains, carving canyons and burying entire regions in darkness and snow hundreds of meters deep. But the most dangerous weather formed in the twilight zone. Storms of steam-eating ice, lightning curtains that stretched for kilometers, hurricane tunnels formed between mountain passes. Some settlements built enormous storm break walls, half city, half fortress, to withstand these forces. Others dug deeper underground, learning to live beneath the fury. To survive here, humanity did not simply adapt to the weather. It adapted to a world where the weather was the dominant force of nature. 600,000 years later, a planet of three kingdoms. By 100,000 years, Earth became clearly divided. The Dayfire domain, a world of unending sunlight. The ground is glass. The mountains sparkle with crystallized minerals. Winds howl like metal. Only microbial life persists, the eternal frost. A frozen empire covered in black ice. Temperatures plunge to unimaginable lows. Under the ice, glowing ecosystems bloom. Nightlife, literal and alien, survives without ever seeing the sun. The twilight ring, the home of humanity. A narrow cradle of life, endlessly circling the planet. Its skies shimmer with violet and gold. Its lands shake, storm, heal, and grow. Its people endure. The stationary Earth had become a world of three kingdoms, each beautiful, terrifying, and eternal. 7. 1 million years later. A planet reborn. A million years after the stop, the Earth is unrecognizable. The day side resembles Mercury's surface. Crusted deserts stretch to the horizon, carved into fractal patterns by ancient winds. The sun, hanging in the same point forever, burns a blackened halo into the sky. The night side has transformed into a giant cryosphere. Ice sheets hundreds of kilometers thick bend under their own weight, creating slow-moving rivers of frozen glass. And the twilight zone, once narrow, has expanded slightly due to atmospheric redistribution. New forests of low-light plants spread across the land like violet oceans. Massive grazing creatures roam the plains, their fur shimmering in soft gradients that mimic the eternal horizon. Humanity still survives, smaller, wiser, shaped by a world without rotation. They live in layered cities carved into mountain rings, in underground caverns warmed by geothermal rivers, in surface settlements protected by radiant domes. Their myths speak of a time when the sky moved. Their science speaks of a world constantly balancing between fire and ice. Their eyes, adapted to the twilight, reflect a horizon that never changes, yet contains the entire story of their existence. Segment 7. Into the Eternal Night. For generations, humanity survived by staying close to the twilight, that fragile band where warmth meets cold, where the sun lingers forever on the horizon. But eventually, curiosity grew stronger than fear. Stories of strange creatures living beneath the ice. Rumors of geothermal caverns glowing like underwater cities, and whispers that the night side held secrets older than the stop itself. All of these pushed humanity toward its next great frontier. This is the story of the Night Expedition, the journey that tested everything humanity had become. 1. The call beyond the twilight. Every few decades, a group of explorers would attempt to push the boundaries of the habitable ring. Some traveled a few dozen kilometers into the cold darkness before turning back. Others vanished, swallowed by fractures in the ice or storms so silent they didn't even leave footprints. But one day, a signal was detected, deep beneath the night side. Seismic sensors picked up steady vibrations, pulses too regular to be natural. They repeated every 19 hours, echoing through the ice like a heartbeat. No one knew their source. No one knew their meaning. But they were not random. A team of 12 was assembled. Engineers, biologists, geologists, historians, and 2 young volunteers who simply refused to believe that the night side was a place meant for silence alone. They called themselves the Lantern Team. because they intended to carry light into a world that had never known it. 2. The descent into darkness. Crossing the boundary from twilight to night was like stepping out of existence. The last sliver of golden horizon dimmed behind them, swallowed by a sky as black as obsidian. The temperature dropped so quickly that frost formed on their suits within seconds. Their breath crystallized into tiny diamonds that drifted behind them like a trail. Ahead lay a continent of endless ice. Sharp ridges curled like the backs of frozen waves. Valleys plunged into shadowy depths. Wind blew slowly here, creeping across the ground with a whispering sound that seemed almost alive. The Lantern team traveled in armored crawler vehicles, low, wide machines built to withstand the crushing cold. The treads groaned with every movement, leaving winding trails that would soon be erased by drifting snow. As they pressed deeper, the sky began to change. At first, it looked completely black. Then, faint colors shimmered across it, blues, greens, purples, dancing like silk in the void. This was the eternal aurora, a ribbon of electromagnetic fire born from the frozen magnetic field, painting the night in silent motion. To the explorers, it felt like traveling through a cathedral made of stars. 3. The ice that breathes. After days of travel, the team reached a massive rift cutting across the night side like a wound. The ice walls descended for hundreds of meters, glowing faintly from within. It was warm. Not warm by human standards, but warm enough that vapor rose from cracks in the ice. The source was geothermal energy, trapped under layers of frozen crust. And then they heard it, a rhythmic thumping echoing through the ice. Deep, slow, living, the same pulses detected by the sensors. They set up camp along the edge of the rift. Using drills reinforced with diamond composite, they began carving a path downward. Ice cracked and sang beneath them, creating haunting harmonics that rang in the frozen air. On the fourth day, they broke through into a cavern. What they found exceeded every myth. 4. The under-ice world. The cavern was enormous, a hollow continent beneath the frozen shell of the night side. Stalactites sparkled like frozen lightning. Liquid water flowed in glowing rivers warmed by geothermal vents. Vast fungal forests spread across the rocky floor, illuminating the cavern with a soft green-blue light. But the most astonishing part was the life. Blind, pale creatures with bioluminescent patterns swam through the water. Strange reptilian mammals moved through the fungal forests, their skins glowing faintly like breathing crystals. Insects the size of a human hand scurried across the walls, clicking in patterns that resembled language. This was not merely survival. This was evolution. An entire ecosystem had formed in total darkness, a world parallel to humanity's, untouched by sunlight, shaped only by heat and time. The Lantern team recorded everything: samples, scans, sounds, and stories. They documented species no surface human had ever imagined. They even found tunnels hinting that this subterranean ecosystem spanned a vast network beneath the ice. But the pulses were still ahead, deeper inside. Waiting. 5. The heartbeat of the night. Following the vibrations, the team traveled deeper into the cave system. The tunnels narrowed and widened, sometimes lit by glowing plants, sometimes swallowing them in absolute darkness. Finally, they reached a chamber where the sound was louder, vibrating through their bones. At the center stood a monolithic rock column. Its surface was smooth, shaped by impact or pressure. Deep fissures glowed with orange-red light from molten rock below. Every 19 hours, the chamber shook with a pulse, a deep, resonant thud. It wasn't alive. But it sounded alive. Scientists later theorized it was a colossal geologic vent, a massive valve of stone and pressure releasing energy at regular intervals. Over millions of years, it had shaped the entire subterranean biosphere, a mechanical heart of the frozen world. Yet for the explorers, it became something more, a symbol that even in eternal night, the Earth still had a heartbeat. 6. The return. And what it meant. The Lantern team spent 2 months underground before returning to the Twilight settlements. They brought evidence of ecosystems thriving in darkness, proof that life had not only survived but evolved into entirely new forms. Their journey changed everything. Humanity learned that the night side was not dead, that Earth still held secrets, that new worlds existed just beneath their feet. Soon, new expeditions were launched, scientific missions, cultural exchanges, exploration teams. The night side slowly became less a place of fear and more a place of wonder. Children grew up hearing stories not of monsters in the dark, but of glowing forests and rivers of warm water. The dark was no longer an enemy. It was a frontier. Segment 8. Into the furnace of the day side. For centuries, the day side was considered a forbidden land, a place where metal softened, where winds howled with the force of hurricanes, and where the sun burned with an intensity no living being could endure. But just as curiosity once pulled humanity into the eternal night, it now drew them toward the blazing frontier on the opposite edge of their world. This is the story of the Solar Expedition, the mission that dared to cross the line between survivability and fire. 1. The edge of the inferno. The twilight band gradually brightened until the sky took on a deep golden color. Shadows grew sharper, the ground warmer, and the air shimmered with invisible heat. This was the solar threshold, the razor-thin region beyond which no human had ever walked unprotected. The expedition team stood before it, wearing suits reinforced with ceramic composites and reflective plates. Their vehicles resembled rolling fortresses, designed to deflect heat rather than absorb it. Even from a distance, they could feel it. A wall of heat so powerful it seemed to breathe. Before crossing, they looked back at the horizon, the soft golden band where humanity lived. Behind it lay the endless dark they had conquered. Ahead lay a world that seemed alive with flame. And then they stepped forward. 2. The roaring plains. The first few kilometers felt like walking into the mouth of a giant furnace. The ground, once solid rock, transitioned into dark volcanic glass that melted into rippling pools. Dust devils of superheated air spiraled upward, tearing at their equipment with invisible claws. Every metal surface glowed faintly. Every breath carried the taste of iron. Every step was a negotiation with danger. Yet the dayside was not empty. Far in the distance, heat lightning burst from cloudless skies. Rivers of molten basalt carved slow, glowing paths through the land. Towering mineral formations rose like crystal skyscrapers, shaped by millennia of relentless sunlight. It was a landscape sculpted by fire, harsh, violent, yet mesmerizing. Even here, life found a way. 3. Creatures of fire and light. The team expected nothing to survive in such extremes. They were wrong. Along the basalt fields, they encountered organisms unlike anything on the twilight or night side. Translucent worm-like creatures swam beneath the surface of glowing rock, feeding on minerals heated near their melting points. Their bodies shimmered with refracted light, glowing like molten glass. In the distance, towering basalt creatures lumbered slowly across the plains, massive, tortoise-like beings with shells made of crusted mineral layers. Their movement was slow, but steady, powered not by sun, but by internal chemical reactions adapted to heat that would kill any other organism. And then there were the light gliders, thin, kite-like creatures that floated on thermal updrafts, glowing faintly as sunlight passed through their translucent wings. For the first time, humanity realized life on the day side was not just surviving. It was thriving, in forms shaped entirely by heat. 4. The City of Mirrors. After days of travel, the expedition reached the structure that had sparked the mission, a glittering formation reflecting sunlight miles away, initially thought to be a natural crystal outcrop. But as they approached, they realized it wasn't natural at all. Before them rose a sprawling geometric construction made entirely of reflective mineral plates, towers, bridges, domes, corridors twisted like fractals in every direction. It was a city, an ancient one. Each surface was polished to mirror perfection, designed to deflect the sun's deadly heat. The structures cast shadows in precise patterns, creating pockets of survivable temperature within an otherwise lethal environment. Someone, or something, had built it, but no inhabitants remained. The city was silent, filled only with the hum of wind sliding across reflective stone. Inside its central chamber, the explorers found intricate mechanical sculptures, devices that used solar intensity to power movement, storing energy in crystal batteries older than written history. The team realized they were standing in a relic of a civilization that had existed long before the stop, creatures or beings that once mastered the furnace of the dayside. 5. The Solar Archives. In the deepest chamber, they found something unexpected. A vault filled with crystalline slabs etched with patterns resembling writing. Each slab glowed faintly when touched, projecting fields of light that shifted like flowing script. The symbols were too complex to decipher, but their meaning was unmistakable. This was knowledge, preserved, intended to last forever, or as close as possible. Geologists estimated the city was millions of years old, far older than humanity, far older than any previously known species. This was the first evidence of a pre-human intelligent civilization. And somehow, they had survived, perhaps even prospered, in the furnace of a world that never saw night. Why they vanished remained a mystery. But one thing was clear. Humanity was not the first to call this frozen, burning world home. 6. The Return, a new understanding. When the solar expedition returned to the twilight belt, they brought back samples, recordings, and images of a city made from mirrors and light. Their journey challenged everything humanity believed about the planet, about evolution, and about the timeline of intelligent life. Two civilizations had risen on the same world, one in fire, one in twilight, separated by millions of years. Humanity realized that they were not living in the first age. They were living in the next chapter of a much older story, and the dayside, once feared as a realm of death, became a treasure trove of history, a blazing archive waiting to be decoded. Segment 9. The Fusion of Civilizations. The return of the solar expedition marked the beginning of a new era, one that historians would later call the Great Convergence. For generations, humanity had believed itself alone, the sole intelligent species to ever shape the Earth. But the mirrored city in the blazing lands shattered that certainty. Beneath the scorching sun lay proof of an ancient brilliance, a civilization sculpted from heat, reflection, and sheer endurance. Now, for the first time, two worlds began to merge: the twilight dwellers and the architects of the burning day. Their knowledge, though silent and ancient, was about to reshape the destiny of the survivors. 1. The Crystal Language. Decoding the crystal archives became the greatest scholarly challenge in human history. The slabs responded to touch, lighting up with shifting symbols that behaved more like a living script than a written one. Instead of separate letters, the patterns flowed into one another, like strands of glowing DNA. It quickly became clear this was not a language built on sound. It was built on light. Meanings changed depending on angle, color, and the intensity of illumination. The archives were essentially three-dimensional stories encoded in beams and shadows. It took years just to understand the structure. decades to decode the first few slabs, generations to piece together the earliest fragments of meaning. But what they uncovered was extraordinary. This ancient civilization, now called the Luminants, had thrived in the furnace of the dayside long before humans walked the earth. Their biology was adapted to heat, their cities built to survive it, their culture centered around reflection and energy. They spoke in radiance, they wrote in geometry, and they thought in patterns of shimmering logic. Humanity was not just reading another species' history, it was learning a completely new way to think. 2. The mirror technology revolution. The Luminant designs changed everything. Their mirrored structures were not simply buildings, they were machines. Each panel performed a function. Some deflected heat with eerie efficiency. Others focused light to power ancient engines. Still others seemed to store energy in ways no human material ever could. For the first time since the stop, humanity gained access to abundant energy beyond what wind and geothermal systems could provide. Engineers replicated small-scale versions, reflective towers that generated limitless thermal currents, crystal batteries that charged in seconds and lasted for years, heat shields that made deeper solar exploration possible. Cities in the twilight belt grew taller, brighter, more resilient. Night-side stations, once fragile outposts, expanded into fully functioning colonies powered by solar heat transported across continents. Humanity had discovered fire for the second time. Only now, the fire was the sun itself. 3. A new understanding of the planet. With Luminant knowledge, geologists decoded mysteries that had puzzled scientists since the stop. The constant heating of the dayside created deep convection cycles beneath the crust. These currents fed massive volcanoes, reshaped continents, and drove strange atmospheric rivers that flowed toward the twilight zone. And deep beneath the burning plains, humanity found something else. Hollow geothermal chambers lined with reflective crystals, functioning like enormous natural power plants. It became clear the Luminants had not merely adapted to the dayside. They had harnessed it on a planetary scale. The Earth had once been alive, with structures that no human could see before the stop, hidden in the blinding heat. Now, they helped keep humanity alive. 4. The cultural shift, light and shadow. The discovery of an ancient solar civilization transformed human culture more profoundly than any technology. For the first time, humanity understood itself as part of a lineage, not the beginning of intelligence, but the continuation of it. Children in twilight towns grew up hearing stories of the Luminants, the mirror builders, the firewalkers, the people of blazing cities. Artists began incorporating reflective motifs into their work. Architects designed curved towers that shimmered like the solar city ruins. Musicians imitated the harmonic tones produced by crystal slabs. Entire philosophies emerged around the idea that intelligence adapts to its environment to the point of becoming indistinguishable from it. That the Luminants were not just a species, but a blueprint of survival. Humanity's identity shifted from one of isolation to one of inheritance. 5. The second expedition. Into the deeper furnace. With new mirror armor and Luminant-inspired technology, a second solar expedition was launched. This time, they ventured far deeper than the first team ever could. Into regions where heat warped the horizon, where the sky glowed white, and where the air itself seemed to burn. What they found astounded them. A subterranean Luminant vault, sealed beneath layers of fused rock. Inside, perfectly preserved by intense heat, lay mechanisms still functioning after millions of years. These devices projected images of the world as it was in the Luminant era. The Earth bathed in daylight from pole to pole. Oceans shimmering under constant sun. Green continents rising toward a cloudless sky. A world before the stop. Humanity realized something staggering. The luminance may have existed while Earth still rotated. They had not evolved because of the stop. They had survived despite it. Which raised a far more unsettling question. What caused the stop in the first place? And did the luminance know it was coming? 6. A growing mystery. Hidden within the vault was the most haunting artifact yet. A crystal sphere engraved with flowing patterns that shifted into new forms under light. The more scholars studied it, the more they realized. It was a warning. But a warning about what? A cosmic event. A planetary collapse. A force that stopped the Earth once and could stop something else again. The discovery sent ripples through human society. Was the stop a freak accident or something intentionally triggered long ago? And if so, by whom? The Twilight world, once unified by survival, now found itself divided by possibility. Some saw the luminance as allies. Others feared them as precursors to an ancient disaster. But all agreed on one thing. Humanity needed answers. Even if the truth waited in places far more dangerous than the furnace of the dayside. Segment 10. The search for the first cause. Even with luminant technology transforming their society, one question hovered over humanity like a shadow cast by an unknown star. What stopped the Earth? The planet had spun faithfully for billions of years. Its rotation was woven into every law of motion, every climate pattern, every biological rhythm. For it to stop, not slow, not wobble, but freeze, defied everything science understood. Surviving the aftermath was one thing. Understanding the cause, that was another. The luminant vault hinted at a warning left millions of years earlier. But without full translation, it remained an echo of a voice no one could hear. Humanity needed clarity. They needed truth. And so they began the greatest investigation in their history. 1. The Celestial Division. A new global institution rose in the Twilight Belt, the Celestial Division, a coalition of scientists, linguists, engineers, and philosophers dedicated to decoding the luminant archives and searching for cosmic clues. Its building, shaped like a spiraling mirrored tower, reflected the eternal half-sun in shifting patterns of gold and silver. Inside, scholars worked day and night, though those terms had lost their meaning long ago. They studied everything. The fractures in tectonic plates, the alignment of ancient mineral structures, the sudden halt recorded in fossil layers, the luminant crystal engravings that seemed to warn of cycles, not accidents. Slowly, the pieces began to form a picture. Not complete, not comforting, but undeniable. The stop was not a freak occurrence. It was part of a pattern. 2. The cosmic scar. Astronomers in the Twilight Belt had always struggled. With half the planet in darkness and half in blinding sunlight, telescopes worked only in carefully shielded observatories built along the cold side. Yet the night sky of a stopped Earth revealed something startling. A faint arc, barely visible even through advanced instruments, stretching across the stars like a healed wound in the fabric of space. A cosmic scar. It wasn't a natural nebula, nor a comet trail, nor anything catalogued before the stop. It was a disturbance, a ripple, a fracture, as if something unimaginably massive had passed through this region of space thousands or millions of years earlier, hand-bending the laws of physics behind it. The Celestial Division realized the scar aligned perfectly with the orbital position Earth held when the stop occurred. The planet had rotated into the path of something, not a physical object, but a disturbance in space-time itself. Something that interacted not with matter, but with motion. 3. The luminant prediction. Meanwhile, linguists finally made a breakthrough. The crystal sphere recovered from the solar vault began to reveal its meaning. Its shifting patterns weren't decorative, they were a map. A dynamic representation of the Earth's position through cosmic epochs. And at its center was a symbol repeated again and again, a spiral crossed by a straight line, a spin cut short. The luminance had known about the cosmic scar. They had tracked it, studied it, predicted its trajectory across the galaxy. They called it, once translated, the Earth's shadow. According to their recordings, it swept through star systems every 27 million years, leaving behind worlds that had lost rotation, gravitational balance, or magnetic fields. It wasn't malicious. It wasn't intelligent. It was simply a cosmic force with consequences beyond comprehension. A ripple. A wave. A phenomenon older than any civilization, now or ancient. And Earth had crossed its path. 4. The shattering realization. The Celestial Division reached a conclusion that chilled every surviving human. The Earth would have stopped no matter what. Humanity did not cause it. No ancient civilization triggered it. It was the universe itself. The stop was not a curse, not a punishment, not an accident. It was a natural event in a cosmos far stranger than humans had ever imagined. A wave through space-time that froze rotational momentum, leaving solar systems altered forever. And the luminance, they had seen it before. Their warnings were not about the first stop. They were about the next one. 5. Preparing for the second shadow. If the Axis shadow passed Earth once, it could pass again. Not soon, not in any timescale relevant to living humans, but eventually. And its effects were unpredictable. Could it halt orbital motion next time? Disrupt magnetic fields? Freeze tectonic activity? Or trigger changes no one had ever witnessed? The message was clear. Survival was not a one-time victory. It was a long-term project. The Celestial Division called for a new era of unity, a global effort to prepare future generations for whatever might come in the distant age when space itself shifted again. The Twilight Belt responded with determination. Cities expanded their mirrored towers. Energy networks grew stronger. Knowledge centers multiplied, ensuring nothing was lost. And humanity vowed never again to be unprepared for a cosmic event. For the first time since the stop, they felt not just fear, but purpose. 6. A new cosmic identity. The revelation changed humanity's view of itself. They were not the fragile victims of a dead world. They were the inheritors of a universe shaped by forces vast and unpredictable. The luminance survived their era. Humanity survived the stop. And now, the two civilizations, separated by millions of years, joined by shared struggle, formed a single legacy. The legacy of those who endure. People began to mark their calendars not by seasons or months, but by epochs of light. A cultural reminder that survival came in cycles, and that every generation lived within a chapter of a much larger cosmic story. Humanity had finally found its place. Not at the center of the universe, but as a participant in its vast, mysterious rhythm.